Okay, let's pick things up where we left off in class today with example number 4. And in this example, we're going to try to solve an absolute value inequality, that is x minus 3, or the absolute value of x minus 3 is greater than or equal to 5. So we'll take two approaches to it. Geometrically, we'll look at it in terms of a number line, and then we're going to also look at it in terms of trying to solve two inequalities and applying some algebraic reasoning. But first and foremost, it's important that we try to understand what the expression means. Okay, so let's take down these 2 points here. So using a geometric interpretation, x minus 3 is a translation of the number x 3 units to the right of 0. Okay, so what we're going to do is the number x, wherever that happens to be, we're going to translate it 3 units to the right of 0. So let's say that 0 happens to be, well, why don't we put it on this end here? We'll go 3 units to the right. Okay, so 3 is going to be the number that we're going to reference. So what I mean by that is in the second statement, which is here, that expression can be interpreted as the number x is at least 5 units away from positive 3. Okay, so at least 5 units away from positive 3. So just in looking at this number line and thinking ahead, I'm recognizing that I'm just going to shift these, and for good reason, and you'll see that in a moment, is that let's travel 5 units from 3. And what we'll do is we'll see that we're going to end up over here at this particular location. And at this value, we have a value of 8. Okay, so plus 5 units. At least 5 units away from positive 3, okay, could also mean that we move in the opposite direction. So we could very well start at 3 and move backwards to this location here on the number line, at which we would be at minus 2. Okay, and that was as a result of subtracting 5 from positive 3. So when we look at the expression that we have here, or our representation, if we end here at 8, and we end here at minus 2. Okay, just going to move this out of the way for now, that's for later. We don't have a full solution or a complete solution to the inequality that's being posed. All we have right now is a solution to the inequality. The absolute value of x minus 3 is equal to 5. Okay, that's the solution we have now. So we'll just make an intermediate conclusion, and we'll build from there. So therefore, this equation has solutions as follows. Okay, so it's a small set. Those are the solutions to that equation. So what we can do now is let's go back in and let's look at the language of the problem. Okay, notice how we have this expression here. Okay, it's at least 5 units away from positive 3. The words at least in math means that it could be 5 units away, or is 5 units away, or it's more than 5 units away. So this symbol x greater than or equal to symbol is really telling us that x minus 3 is at least 5 units away. Okay, so that's what we need to think now. So if we resketch our number line, okay, we're going to tighten up the scale on this a little bit more. Let's, for instance, say minus 2 is here, and that 8 is here. Two of the solutions, right, are 8 or negative 2. Now, because of the inequality, or the greater than symbol, we're going to have an infinite number of solutions. In fact, if it's at least 5 units away from positive 3, then we could expect that the solutions are going to be, in this case, x is greater than or equal to 8, and over here, x is going to be less than or equal to minus 2. So thus far, we'll make a conclusion. So based on this strategy, or the strategy of a number line, we could now say, therefore, x minus 3, or the absolute value of that, is greater than or equal to 5. And I'm going to use that symbol we were using earlier for all, right? For all, looks like an upside down A, for all x belonging to. Okay. Now we could use two inequality statements. We could say x being less than or equal to minus 2, or x greater than or equal to 8. We could also represent the solution using a different notation. And in fact, I like this one a lot, because you're going to see it being used throughout the textbook. We could also say that this absolute value inequality is true for all x's, but expressing the x's in terms of interval notation. So if anything's smaller than or equal to negative 2, we could start with negatively large numbers. We could work our way up to negative 2 and include negative 2 in our solution set. Or we could also begin at positive 8 and then grow positively large towards infinity. So these are two appropriate ways of communicating your solution to that problem. Now notice that I did write alternatively on the previous slide. Aside from using a number line, what we could do is the following. We could use our definition of absolute value as follows. From this inequality, we can derive the following statement, that x minus 3 is greater than or equal to 5, or the negative of x minus 3 is greater than or equal to 5. Okay. If we analyze these as two separate cases, but both cases representing answers to the inequality, we should come up with the same answer as we did with our number line. So let's go with case 1. And by solving this equation, or rather inequality, which is solved like an equation, we can see that x is greater than or equal to 8. Under case 2, the negative of x minus 3 is greater than or equal to 5. If you divide both sides by minus 1, what we're going to see is x minus 3 being less than or equal to negative 5. Recall that when multiplying or dividing by a negative changes the direction of the inequality symbol. So what that means is if we carry through with this is by adding 3 to both sides, we come up with the same solution that we had before. So compare this back to what we had originally. You can see that this solution is being represented here, which is also here in interval notation. And you can also see the other solution being represented there, here, and also here with interval notation. Okay, so at this point in time, you should have enough examples to support your work for page 16, numbers 1 through 5. Tomorrow what we'll do is we'll investigate one slide further. We're going to investigate what happens when we try to define the absolute value of a number as a function, and then we'll actually get into a little bit of graphing.